So this is the practice for the reaction bond energies. For number one, it's asking in the reaction between hydrogen and oxygen gas, what's the change in enthalpy? That's just another way of saying the total bond energy for this reaction. So first we have to actually write out the reaction of hydrogen and oxygen gas. And now that we know that that's the actual reaction, we need to see what the molecules look like. H2 is that, and there's two of them because of the coefficient, and oxygen looks like that. And you would know that that's how oxygen looks like based off the total number of valence electrons and then drawing a bone structure and trying to get all the atoms to have a filled octet. And there's only one molecule of oxygen. For H2O, it looks like that, and there are two of them. So now we can look at what's being broken, which is always the reactants, and being broken means it's a positive, and what's being formed, and that's the products. And if it's being formed, it's always a negative. So first, let's do the broken. So we have two HH bonds, which is 2 times 436 kilojoules, which is equal to 872. And then we also have one O double bonded O, and that is 499 kilojoules. So right now we can calculate the total, and that's 1371 kilojoules, and this is positive because all of these are being broken. Now we can also do the formed. In this case, you have two of these OH bonds in each molecule, and you have two molecules of them, so 2 times 2 is 4 of the OH bonds, and each OH is 463, so 4 times 463, and what we get for that one is 1852 kilojoules, and it's negative because these are being formed. So 1371 kilojoules minus 1852 kilojoules, you're just finding the sum, is negative 481 kilojoules for this reaction. For number two, it's asking for the energy of a reaction, which is combustion of propane. And I wrote down what the molecule of propane actually is. And in this case, we know that it's got to be a negative number because it's combustion, meaning it's going to release energy. And because it's propane, which is a form of, it's something that you use when you need a lot of energy, the number that we're going to get is going to be pretty big. So first thing we got to do is write out a reaction for the combustion of this molecule, and we can do that. Combustion is always with oxygen, and it yields carbon dioxide and water. And in this case, to match all the coefficients, that should be 4, this should be 3, and there should be 5 oxygens. That's the balanced reaction. So in drawing out the bonds and the structures for this propane molecule, what you have is 3 carbons, and you have a total of 8 hydrogens. Everything on this side is being broken, so we're working with the ones that are being broken first. So we have 1, 2 carbon to carbon bonds that are being broken. And that makes sense because if you have 3 carbons and all 3 are connected to each other, then you can only have 2 bonds worth of carbon to carbon. And as far as the hydrogens, carbon to hydrogen bonds, Well, in this case, because every hydrogen is bonded to a carbon, you have as many bonds as there are actual hydrogens. So in this case, 1, 2, 3, 4, 5, 6, 7, 8. So that's what's being broken. And we also have oxygen over here. And we know that oxygen is that. So we have one bond of O to O, but there's 5 of these molecules, so that should be 5. When you plug in the numbers from the data table, so 2 times, in this case, 347, we get 694. When it's 8 times 413, we get 3304. And when it's 5 times 498, we get 2490. And because all of these are being broken, they're all positive. So in this case, it's 6488 kilojoules, and that's positive. So we calculated all the reactants, and now we need to do the same for the products. So these are the ones that are being formed. CO2, we know, has that kind of a structure. So there's 2 of the C double bonded O's in each molecule, and there's 3 molecules worth, so 3 times 2, 6. So 6 times 805. And that should get you 4830 kilojoules. And then we also have H2O, which is that. So you have per each molecule an OH bond, 2 of them. And you have 4 of those molecules, so 4 times 2 is 8 of them. So 8 times 464 kilojoules. And that should get you 3712 kilojoules. So the total for that, for the amount of energy that's being formed, is 8542 kilojoules. So the sum of what's being made and what's being formed, we should get negative 2054 kilojoules for this entire reaction. And for the final question, we have hydrogen and chlorine gas. Once you have the actual reaction written out and balanced, you draw out the molecules, and based off the number of valence electrons and trying to get the filled octet for each atom, those are the structures that you end up with. So we have broken 1 H to H bond and 1 Cl to Cl bond, and we have formed 2 H to Cl bonds, and the total should be negative 183 kilojoules.